Hello everyone, welcome back to your digital classroom, Report Data with SKD. Today, let me discuss one of the very important concept in operation research that is called the assignment problem. Let's take a scenario in which you have 5 jobs and 5 different employees, those who can perform all the 5 jobs and will charge you something for each and every job, right? Now, being an operation manager, your job is to conduct all the job to basically complete all the jobs in minimum cost, right? So your objective is in minimum cost, you have to complete all the jobs from these 5 employees, five jobs from 5 employees. Here the role of assignment problem come into the picture. In case of assignment problem, what you do is you will basically assign the jobs to the employee in a manner so that minimum cost will incur, right? And for this, we use one of the method called Hungarian method. So I request you to please watch this video till end, because in this video, I'm going to discuss first of all, what is Hungarian method? And second one is what is the different steps? And of course, I will solve one complete problem in this, a complete problem of minimization in this to tell you how to perform this, right? So at the end, we will have one solution that we can say it's an optimum solution with the help of Hungarian method, right? So let's start with the assignment problem. Now, first of all, assignment problem, we solve the assignment problem, or we will get the optimum solution with the help of Hungarian method. So we use Hungarian method to find out the optimum solution. This is the first thing. Now, the most important thing is Hungarian method is only meant for problem of minimization. So if you have a problem of maximization, you have to do something else, right? So today I'm going to discuss only the problem of minimization, right? So in case if you have a problem of minimization, you can use Hungarian method. Of course, in problem of maximization, we use the Hungarian method, but we'll do some little bit trick in that, right? So we'll discuss the minimization problem with Hungarian method today, right? Let's take a scenario. Now in a department, you have 5 employees and 5 jobs. Now you have to assign these jobs to the employees so that their total man hours will be minimum, right? Of course, the time is there, so you always want that the job must be completed in less number of hours, right? So minimum, right? So this is basically the problem of minimization, right? Now how to go step by step using Hungarian method to find the optimum solution. Let's move on. Now in this case, what we will do is the first step that we'll do is we'll go for the row reduction. Now what is row reduction? Let's just check. In case of row 1, you have basically 10, 5, 13, 15 and 16. Out of this, whichever is the lowest one, so 5 is the lowest, let's take 5 and reduce rest of the number with 5, right? Of course, all the numbers is 5. So this will be 5, this will be 0, this will be 8, this will be 10, this will be 11, right? Now for second, this is the minimum, so this will be 0, this will be 6, this will be 15, this will be 10, and this will be 3. In case of C, you have 2, so this will be 0, this will be 0, this will be 0, this will be 5, and this will be 8, right? In case of D, you have 7, so this will be 0, this will be 4, 2, 0, and 5. In case of row, you have 4 as a minimum, so this will be 0, this will be 3, this is 5, this is 6, and this is 8, right? So now this way you will go for the row reduction, right? So now row reduction is done. Let's move on. Now after row reduction, you have this particular matrix, right? Now what you have to do, you have to go for a column reduction. In this new matrix, in this particular matrix, you have to go for a column reduction, right? Now how you will do the column reduction? Same way, minimum number of the column and subtract all the number from that minimum number, right? So let's move on. Now in this column, in this particular column, you have 0 as a minimum number. So when you reduce 5 minus 0, it's same. 0 minus 0 same, 8 minus 0 same, 0 minus 0 same, and 3 minus 0 same. So this column will remain same. Now go for column 2. Again 0, so this will remain same. Column 3, again 1 is 0, so this will remain same. And column 4, again 0, so this will remain same. And column 5, again 0, so this will remain same, right? Now in this particular situation, all the columns are having at least 1, 1, 0. So all the column will remain same. But some situation comes when you may not have, maybe you have 2 columns with 0 and rest 3 columns may not have 0. So in that case, you have to take the minimum number and reduce it, right? So now after the column reduction, you have basically this matrix. So you row reduction and column reduction. After row and column reduction, this is the final matrix that you have. Now what you have to do? Now here, once you complete with your row reduction and column reduction, now you have to go for the assignment, right? So how you'll do the assignment? I'll just check the row, right? So what we have to do, there is a simple rule, you can say. A rule is what? If you have any row or column more than 1 0, don't assign, leave that, right? So we will go row wise and then we'll go column wise. So let's move on. This is, we are doing row wise. Now the first row, we have how many zeros? 1 0 only. So we can assign, right? So I have assigned this, and when I have assigned this, what it means? I have assigned the job 2 to A, right? Job 2 to A. So when I have assigned this, job 2 is over. Is not available for anyone, right? Then go for row B, of course, employee B. Employee B, again in this, we have only 1 0. So we can assign this, right? And we'll say job 1 is no more available. Now I'll move on to C. Now in this case, we have basically 3, right? So leave this, need not to assign. Now go for row D. We have how many? 1 and 2 zeros. Fine, leave it, right? Then E, we have only 1 0, right? We have only 1 0. So what we can do, we can assign and say job 4 is no more available, right? So this is row wise reduction is done. A, B, C, D, E, row wise reduction is done. I have taken the row in which you have only 1 assignment and I have assigned it, right? Now let's go for column reduction. Now, in case of column reduction, we have only 2 columns, this column and this one, right? So column 3, we have how many zeros? 1 0 is there, so I can assign, right? And when I'm assigning this, what I'll do, I will cut the row wise. Clear? So when I'm assigning column wise, I'll cut the row wise. When I'm assigning row wise, I will cut the column wise. Clear? Comes to the fifth row, right? Fifth column, sorry. 1 2, no 0 is available. So nothing can be done. Okay. So now assignment row wise and column wise is done. Fine. Now you have to check the condition for optimality. And what is the condition for optimality? Condition for optimality is number of rows oblique columns must be equal to number of assignments, right? Now in this case, if you check, you have a 5 rows and how many columns? 5 columns, right? So number of rows or column, so 5, right? And assignment is 1 2 3 and 4. So 5 into 4. Whereas what you must have 5 into 5. Number of rows in column equal to number of assignment. But this condition is not there. You have this condition. So what it means? Your solution is not optimal. Clear? So now the first step is over, where you have to check whether the solution is optimum or not with the help of your Hungarian method, right? Now, when the solution is not optimum, your job is to convert into optimum, right? Now to convert into optimum, again we have to do something, right? We have to do treatment. You can say we have to do treatment. And how will do the treatment? let's talk about this. This is basically your matrix after assignment, right? Now, in this matrix, we will talk about the unassigned cells and the number. So in this one, this is the unassigned cell, this is the unassigned cell, this is the unassigned, this is, right? So especially what I want to say is unassigned cell, the numbers that are not on row or, sorry, not on a straight line. Simple. Find out all the numbers that are not on a straight line. So in this case, we have 8, 15, 2, 6, 11, 3, 5, 8. Now in this particular situation, these are the numbers that are not on line, right? Now out of these numbers, whatever the numbers you have, out of these numbers, right, you have to select the minimum. So minimum is 2, right? So this is what you have to find. So what you have to convert into optimum, you have a matrix. In this matrix, whatever the numbers are not on line, you have to select the minimum number out of that. So it's 2. Now, what do you have to do? Now, in this case, you have to talk about two things. One is the intersection of the line. So we have how many intersections? 1, 2, and 3. 3 intersections are there, right? So this is 1 intersection, 2 intersection, and 3, right? In these intersection point, you have to add this number, right? This number 2 that we have selected in the previous one, we have to add to these number. So this 8 will become 10, this 5 will become 7, and this 0 will become 2, right? And then the number that are not on line, the number that are not on line, the other number not, you have to subtract from these numbers, right? So this 8 will become 6, this will become 13, this will become 0, this will become 4, this is 9, this is 1, this is 3, and this 8 is 6, right? So what we did to convert into optimality, first of all, we add to intersection and we subtract from the number that are not on line. Now the new, after addition and subtraction, we will basically have this. See, so these number was basically intersection point, and these number were basically your number that are not on line. Clear? So now addition and subtraction is done. What next? Again, start assigning the job. Now in this matrix, once you will go to all the steps, this is the matrix. In this matrix, again, let's start on the row wise, fine? So only 1 0 is there, so we can assign this, and we will cut the column. Then move on to the row 2. We will assign this and we can cut the column. Row 3, because we have 2, so leave it. Row D, we have basically 1, 2, 3, so leave it. Row E, we have only 1, so let's assign and cut. Done. Now move on to the column wise. So now we have only 2 columns available, so we'll just go for this column. Column this. How many 2 zeros are there? Leave it. Don't do it. Comes to this one. You have how many? 1. So I'll assign 1, and then I will cut. Fine. Now after doing this, this is basically 1 0 that is still not assigned. Now logically check, can we assign this? Yes. So the employee D is free and job T is 3 is still pending, and I can assign this, right? So I will assign logically this, right? Now in this case, what will happen? Now you have assigned everything. No 0 is left. So your job is over. Assignment job is over. Now let's check the optimality. Fine. Optimality is what? Number of assignment are equal to number of rows or column, right? So Number of rows are 5 rows or column. Assignments are 1, 2, 3, 4, and 5. So your answer is yes. And you have optimum assignment here. So assignment is done. Now you got the optimum matrix, right? Now to find the solution from this matrix. So this is what the matrix that is optimal. And this is the original matrix, the first matrix I have taken here. Right? Now, just compare this optimum with this one and just assign A to 2. So A to 2, right? B to 1. So B to 1, right? Then C to 5th. So C to 5th. Then D to 3. D to 3. And E to, right? Fine. Now, what will be the answer? Minimum number of hours. What are the minimum number of hours? So this is 5. B1 is 3. C5 is 2. D3 is 9. And E4 is 4. So total is 20. So now if we assign the jobs, like I will assign the employee A the second job, employee B the first job, employee C the fifth job, employee D the third job, employee E fourth job, it will be all the jobs will be finished in 23 hours, right? So this way you can find the answer of a problem or a assignment problem, or you can say optimum answer of an assignment problem, right? Hope this is clear to you all. I request you to please like this video, comment any query you have, and share this video with your friends. And also don't forget to subscribe, because you will get the future video on time. Thank you very much. Enjoy your day.